Continuing with section 7.5. This is the third example, and in here what we want to do is probably simplify and get things in cosine and sine. So remember the tangent theta over secant square theta, I can write it as tangent theta times 1 over secant square theta. So which means I can which is actually tangent theta times 1 over secant theta whole square. But 1 over secant theta is cosine theta. So this will become tangent theta into cosine square theta, cosine theta whole square. So when we expand this one, simplify this, we end up getting sine theta over cosine theta for the tangent and cosine square theta d theta. So now the one cosine, this cosine cancels one of the cosines at the top. So I cross the 2 here and we are left with only one cosine theta. So that we have equal to integral of sine theta into cosine theta d theta. Now from here you can do it in different ways. You can say choose the u substitution with probably u is equal to sine theta. Then find the du and plug in the values and simplify it. Or you can use u is equal to cosine theta and do the same process that we do. But I will do it in like a third method. So we know that if we have a 2 here, this quantity is sine 2 theta. So I introduce a 2 here, but then I have to divide by d2. So I have 1 over 2 outside. So inside now my quantity is sine 2 theta d theta. So which is half times the derivative, and entire derivative of sine 2 theta will be negative cosine 2 theta divided by 2. Why divided by 2? Because of this with the theta. Plus c. So we get negative 1 over 4 cosine 2 theta plus c. That is your answer. Next one is 1 over 1 minus cosine theta. So now this is again a problem which we cannot do it in keeping it in this form. So we have to do something, and substitution won't work at this moment here, because if you want to put 1 minus cosine theta equal to u, then the du will have a sine t in it, and we don't see a sine t, so we won't be able to get rid of the t, we won't be able to transform the t into u. So substitution won't work at this moment. But if you recall, now 1 minus cosine t, there is no trig identity which involves just 1 minus cosine t. But 1 minus cosine square t, we have something. So that's what we are going to do here. We are going to manipulate and make the integrand such that I have a 1 minus cosine square t at the bottom. So what do I need to do for that? I will have to multiply top and bottom by 1 plus cosine t. So that integral 1 plus cosine t divided by 1 minus cosine t, cosine square t, is equal to integral of 1 plus cosine t divided by sine square t dt. Now we can split it. We can now write it as two fractions. Now we couldn't write this as two fractions. I have discussed this in class why we cannot do that. But currently, with this quantity we can do that. So we split 1 over sine square t minus cosine t over sine square t dt, which can then be written as, the first one is cosecant square t minus, the second quantity, this can be written as cosine t over sine t times 1 over sine t. Now the entire derivative of cosecant square t is negative cotangent t. And then this one is cotangent and this is cosecant. So let me just write it like this: minus integral of cosecant cotangent t times cosecant t dt. But this is the derivative of, this thing is the derivative of negative cosecant t. So we have the negative sign here. So if you see negative cotangent t into secant t, that is the derivative of cosecant t. So the entire derivative of this quantity will be negative cotangent t plus cosecant t plus c, or secant t minus cotangent t plus, that will be the answer. So now we are going to look at secant. So how do we, again there is a kind of a specific method or specific trick that we need to do. So as we just saw here in the previous problem, we had cosecant square t, and then we had the other term was cosecant t times secant t, cosecant t times cotangent t. So we had a derivative of cotangent, which is negative cosecant square t, and derivative of cosecant, which is cotangent t multiplied by cosecant t. So now with the secant, we get a similar thing when we multiply the secant theta on top and bottom by the term secant theta plus tangent theta. Now when we multiply the secant theta, we get secant square theta plus secant theta into tangent theta. And at the bottom I have secant theta plus tangent theta. Now you see secant theta plus tangent theta can also be written as tangent theta plus secant theta. So I'm going to erase this, although you can leave it like what it is, but just to show you clearly. Now the top is the derivative of the bottom. When we have that situation, we just get the ln of the bottom. So answer will be ln of absolute value of tangent theta plus secant theta plus c. So the next one is the secant cube theta, d theta. So we'll start by integration by parts. So we split it, we write it as secant theta times secant square theta d theta. And we will take the v to be dv to be the secant square theta d theta, because we know the entire derivative of that, which is tangent theta. So we said u is equal to secant theta and dv is equal to, so this is u, and dv equal to secant square theta d theta. So now we integrate the dv. So this left hand side gives me this v, because d and this d means the differential or the derivative, and the integral sign cancel each other, we get v. So v is equal to integral of secant square theta d theta, which is tangent of theta, and du is secant theta times tangent theta d theta. So plugging in here, so we get u v. So u is secant x theta times v is tangent theta, minus integral v, which is tangent theta, times the du. Du is secant theta times tangent theta d theta. So we have secant theta into tangent theta minus integral of, so I have secant theta times tangent square theta d theta. Now here again we will not be able to apply the methods that we learned in section 7.2. So what do? I will expand the tangent square theta, use the trig identity for tangent square theta. So I have secant theta times tangent theta minus integral of secant theta into secant square theta minus 1 d theta, which is equal to, now remember on the left we have, left side is secant cube theta. This is what we are expanding. So we end up getting this equal to secant theta tangent theta minus secant cube theta Now, if I distribute the integral sign, then it will become plus integral of secant theta d theta. Now, left hand side we have the integral of secant cube theta, and we have the same over here with a negative sign. So we add this quantity both sides, end up getting 2 times integral of secant cube theta d theta plus secant theta tangent theta. So this one quantity goes to the other, so we don't have it over here. We get the next one, which is plus integral of secant theta d theta. But now the integral of secant theta d theta we already put up there. So this is secant theta tangent theta plus ln of secant theta plus tangent theta. I'm not putting a c plus c here because just for one step and then we can put the plus c. Now on the left hand side we have 2 secant cube theta, so we will divide by 2. So I have secant theta without the integral sign. So secant cube theta d theta will be equal to 1/2 secant theta into tangent theta plus 1/2 ln of secant theta plus tangent theta plus c. So this is what entire derivative of secant cube theta. So let's go back now. As I promised, we will come back to example 1 once we know that. So now we have this is equal to secant theta tangent theta 1/2 is to be here plus 1/2 ln of secant theta plus tangent theta plus c. Now here we have to go back and convert it to x. I think that's where we started. So first we go back in steps. Remember we did the substitution in 2 steps. But we had to do 2 substitutions. So now we will have to go back to 2 steps. First we go from theta to u. So what is u? U is tangent square root of tangent theta, 2 times tangent theta. So tangent theta will be u over square root of 2. So I can make a triangle with theta because we have tangent of theta is equal to u over square root of 2. So u will come here, square root of 2 will be here, and this quantity will be u square plus 2 square root, or 2 plus u square root. So with this triangle I can see everything. So it will be 1/2. Now secant theta. So secant theta is remember 1 over cosine. Cosine is going to be square root 2 over square root of u square plus 2. So that I have square root of u square plus 2 into over square root of 2 times tangent. The tangent is u over square root of 2. So we get plus 1/2 ln secant is plus tangent is 2 over square root of 2 plus c. Now we replace the u with x square. So the final answer will be, well, this is giving you 2, so we get 1 over 4 now. And then I have u times in this quantity. So u is x square, and I'm getting x square the square root of 2 plus 2 to the 4, and then we have the square root of 2 or 2 at the bottom, which gets multiplied by the 2 here, plus 1/2 ln of square root of 2 plus x to the 4th divided by square root of 2 plus u, is just x square over square root of 2 plus c, and again we can actually get rid of the square root from the bottom, but if you did until here it will be fine. So this is how we do these integrals.